Hey everyone, and welcome to a brand new explainer. You know, as a soil scientist, the question I get asked literally the most is, isn't dirt just kind of boring? Well, today we're going to put on our detective hats and turn what you step on every single day into this epic, billions of years science adventure. I am so excited to share this with you all, because we're going to uncover the incredible clues of exactly how our planet built its living foundation.
Okay, let's dive right into this with a totally mind-blowing fact to shatter everything you thought you knew. If you were to take your magnifying glass outside right now and scoop up just a single tablespoon of healthy soil, you'd literally be holding billions of microscopic organisms in the palm of your hand. I mean, think about that. That means there are more living things in a single handful of soil than there are human beings on planet Earth. Soil isn't dead at all. It's this thriving, bustling metropolis.
But it wasn't always like that. Let's literally rewind our massive chronological clock 4.6 billion years. Back then, our planet had absolutely zero soil. Oceans didn't exist. The air was totally toxic. Earth actually looked a lot more like modern-day Venus, just a giant burning ball of molten rock covered in erupting volcanoes and constantly getting smashed by meteors. It took a truly phenomenal chronological journey to get from that fiery chaos to the green, life-sustaining planet that we know today.
Which brings us to Chapter 1, the Great Rock Breaking. So how exactly did we get from burning molten lava to the soft ground we actually walk on? Well, it all started with rocks. As the magma finally cooled, it formed these incredibly hard igneous rocks like granite and basalt. And then came a process called weathering. Nature basically uses three main methods over millions of years to break those giant parent rocks apart: physical, chemical, and biological weathering. Let's look at physical or mechanical weathering first. Imagine rain seeping into the tiny cracks of massive boulders. When the temperature drops at night, that water freezes. And here's a really cool science fact for you. Water actually expands by about 9% when it freezes. It's just like when an ice cube expands in your freezer. This creates immense pressure, a process called frost wedging, that literally wedges and cracks giant rocks apart. Add in some strong desert winds that act like giant sheets of sandpaper, and slowly but surely, you have entire mountains turning into dust. But nature doesn't just use brute force, right? It uses chemistry. Chemical weathering uses water and air as these invisible weapons. For example, water reacts with minerals in a process called hydrolysis, turning really hard feldspar into soft clay. Or take oxidation. When oxygen reacts with iron minerals, it forms rust. So if you've ever seen soil with that really deep reddish color, you're actually looking at iron oxide. The rock is literally rusting away. And for biological weathering, we really have to look through our microscopic detective glasses. Scientists believe that tiny organisms called lichens, which are actually this amazing tag team combination of algae and fungi, were the true unsung heroes of soil formation. These little guys grew on barren rocks and released weak acids that slowly dissolved the minerals. They were tiny rock destroyers that helped form Earth's very first true soil. Chapter 2: Water and Microscopic Heroes. Okay, so once the Earth cooled down enough, it finally began to rain. And we're not talking about a rainy long weekend here. Scientists think it rained continuously for millions of years. This created massive rivers that eroded the newly broken rock particles and deposited them across the land. These nutrient-rich sediment plains are exactly where ancient civilizations, like the ones along the Nile and the Indus rivers, would eventually thrive. But the real magic happened when life entered the picture. Microscopic cyanobacteria started pumping out oxygen through photosynthesis. When the complex plants they allowed to grow eventually died, their leaves and branches decayed into humus. Humus is that incredibly dark, nutrient-rich material that improves water retention and gives healthy forest soil its rich, black color.
So, the absolutely crucial point here is that soil is a living, breathing, biological metropolis. It's totally full of protozoa, nematodes, fungi, and of course, earthworms. Did you know Charles Darwin actually studied earthworms for 40 years? He literally called them nature's plows, because these little guys can process several tons of soil per acre every single year. They mix it all up, improve oxygen flow, and recycle all those vital nutrients.
Now, if you were to take a giant knife and slice straight down into the earth, you wouldn't just see a brown blur. You'd see distinct vertical layers called horizons. You can actually try this at home. Put some backyard soil in a clear jar with water, shake it out really well, and watch these exact layers settle. It starts at the top with the O horizon, which is the organic layer full of dead leaves. Right beneath that is the A horizon, or topsoil. That's where the magic happens and where most of our crops grow.
Below that is the B horizon, subsoil, trapping clay and iron. Then the C horizon of partially broken rock, all the way down to the solid R horizon, which is the unyielding solid bedrock.
Moving right along to Chapter 3, Climates and Soil Types.
If you've ever traveled, you probably noticed that not all dirt looks or feels the same, right? Well, scientists actually use a specific, almost mathematical formula to figure out exactly how soil forms in different regions around the entire world. That famous formula is known as CLORPT. It basically shows us that soil is a function of 5 things: climate, organisms, relief, meaning whether the land is on a steep mountain slope or a flat plain, parent material, and time. So if you start with rich volcanic basalt ash, you'll get incredibly fertile soil. But if you're on a super steep mountain, the soil might just wash away before it can even build up.
These different ingredients create vastly different properties. You can easily build a basic soil filter at home using paper cups of sand and clay to see this for yourself. Sandy soil has really large particles, so water drains right through it super fast, making it tough for plants to get a drink. Clay soil, on the other hand, has tiny particles that pack tightly together, holding water almost too well, which can actually drown roots. But loam? Loam is basically the superhero of soils. It's the absolute perfect mix of sand, silt, clay, and humus, making it the best soil by far for farming.
The C in that CLORPT formula, climate, plays a massive role too. In hot and wet areas like lush tropical forests, rocks weather quickly and thick layers of soil form much faster. But compare that to dry deserts where there is very little rainfall and hardly any vegetation. There, the weathering is incredibly slow, and as a result, desert soil stays very thin and completely lacks that dark, rich organic matter.
Now, those different environments and the specific bacteria living within them even give us one of the absolute best smells on Earth. Have you guys ever noticed that amazing earthy smell right after a rainstorm? It's scientifically called petrichor. And get this, it doesn't come from the water itself. It actually comes from compounds released by soil bacteria, just proving once again that the ground under your shoes is completely 100% alive.
Chapter 4, Saving Our Living Foundation. We've talked a lot about the billions of years it took to build this crazy ecosystem. But unfortunately, time is not on our side when it comes to replacing what we lose. It takes anywhere from 100 to 1,000 years for nature to create just 1 single centimeter of topsoil. I mean, really think about that. Up to a millennium just to build a layer the width of your fingernail? But human activities? We can completely destroy that very same centimeter of topsoil in a matter of days.
Through massive deforestation, where we completely remove the tree roots that act like a net holding the ground together, through heavy pollution and intense overfarming, we are literally stripping the earth bare. Because of this, we are causing billions of tons of fertile soil to just wash or blow away through erosion every single year. We're losing our living foundation at an alarming rate, and fixing this is absolutely crucial for the future of our entire planet.
As scientists so accurately point out, gold cannot grow food. And since soil actually stores more carbon than the atmosphere and all the plants on Earth combined, our entire survival, our food chains, and the massive fight against climate change all depend on it. We literally cannot have human civilization without healthy soil. If you look at a planet like Mars, it has plenty of rocks and plenty of dust, but it has absolutely zero living, breathing soil. True, Earth-like soil doesn't exist anywhere else in the universe that we know of. So, I'm going to leave you with this final thought for our explainer today. Knowing that you are walking on ancient geology, chemistry, and biology, what will you do to protect the epic, living ecosystem right beneath your feet?